Now that we learned the methods on how to clean data, the last step is to deal with duplicates and missing data. Duplicate data is problematic as it can affect your analysis in undesirable ways. We can drop duplicate data with the drop duplicates method. Here's an example of a data frame with duplicate data. You can see the first and last rows are exactly the same. To drop duplicates in our data frame, we call the drop duplicates method on the data frame. You can see after we call the method, the duplicates are dropped. In this case, the last row of our original data frame was dropped. Now let's work with missing data. Here's an adapted tips dataset. This dataset gives the total bill and amount of tip given for the bill. It also includes other information about the sex of the table, whether there are smokers, the day of the week, the time of day, and the size of the party. You can see the NaN missing values in our data. There are a few ways you can deal with missing values. You can leave it as is, drop them, or fill using various pandas methods. Just like dropping outliers from your data, dropping missing data also needs to be carefully considered. Data can be missing randomly, or there may be a systematic problem in your data that introduce missing values. Remember, we can use the info method to get a count of NaN missing values. In our tips data, you can see we have 244 entries, but no column has that many non-null values, meaning we have missing values in each column. To drop missing values in our data frame, we use the drop NA method on the data frame. If we look at the info of our new data frame, we now only have 147 entries, and each column also has 147 entries. What we get is a data frame with only complete cases. That is, if a row contains a missing value, then the row will be dropped from the data frame. We lost about 40% of our data with this method. If we only lost a few observations, that would be reasonable, but with this many observations dropped from our data set, we need to deal with missing data differently. Keep in mind, dropping columns is also a possibility if most of the missing values are from a particular set of columns. You'll see this in the exercises. To fill missing values, we use the fill NA method. There are various ways we can fill missing values. We can fill it with a user-provided value or some summary statistic like the mean or median. We can fill any NaN missing value with a user-provided value using the fill NA method. Here, I'm recoding all the missing values within the sex column to the string missing. We can also recode missing values from multiple columns at once. To select multiple columns from a data frame, we can use the double square bracket notation. Here, I'm subsetting the numeric columns total bill and size, then recoding all the missing values in these columns to 0. You can see now, when we look at the info, total bill, size, and sex columns no longer have missing values. We can also fill missing values with a test statistic. However, we have to be careful if we want to use a test statistic like the mean to fill in missing values. You have to make sure the value you're filling in makes sense. For example, the median would be a better statistic if you have outliers. Here I'm going to fill the missing values in the tip column with the mean of the tips. We first calculate the mean using the mean method on the column. And we can replace the old column values with the new column values using the fill NA method like before. If you look at the info once more, the total bill, tip, sex, and size columns no longer have missing values in them. The last topic I want to cover is on testing. We can use assert statements to programmatically check our data versus visually checking it. For example, after we drop or fill our missing data, we expect to have 0 NaN missing values. We can write an assert statement to make sure that there are no more missing data. By writing assert statements in our analysis scripts, we can detect early warnings and errors in our data before the final analysis results. This gives us confidence that our code is running correctly and helps when we rerun an analysis with updated data. Here's how assert statements work. If you give it something that evaluates to true, it will return nothing. If you give it something that evaluates the faults, it will give you an error. Let's apply this method to our data. Here's the head of some stock data for Google Alphabet. We have the date, the open, daily high and low, and close stock prices, along with the volume and adjusted close. Now, let's write an insert to test for missing values. I use the not null method on the column to check for missing values. This will return true if there is a value and false if there's a missing value. I'm chaining the all method to test if all the values are not null. But here you can see assert raised an error, meaning there are missing values in the data. I can fill all the missing values in the data frame with the value 0. And now you see the assert statement does not return anything, meaning we do not have any missing values in our data. You'll get more practice with asserts in the last chapter, but for now, let's practice writing assert statements. Well done! You're now able to start working on your own data science projects and use the power of pandas and Python to manipulate data the way you need to answer your question of interest. In these chapters, you've learned how to load and view your data in pandas, visually inspect data for errors and potential problems, tidy data for analysis and reshape it to other shapes if necessary, combine data sets, clean data by using regular expression pattern matching, and functions for complex cleaning steps. Finally, you also learn how to test your data and be proactive in finding potential errors when your analysis is rerun. These are the steps and tools we as data scientists spend the vast majority of our time on. You've learned a great deal in these chapters and now have a solid foundation to explore more packages for specific data processing needs.